this video I'm going to be specifically making it for M105 at IUK. This is going to address concepts in section 7-3. We're going to initially take a look at multiplying radical expressions. Alright, our rule for this basically says that if we're trying to multiply two radicals that have the same root, be it a square root, a cubed root, a fourth root, or fifth root, we can simply multiply what is underneath and keep the root the same. Okay, so we'll go through about 6 examples here. Alright, let's say we've got the 8th root of 10x times the 8th root of 8x to the 4th. Alright, I'm going to remember that there's an imaginary 1 on that x right there, and I'm going to multiply underneath that root just like normal, so my coefficients will be multiplied together and I'll have an 8. I'm going to do the x's. When multiplying like bases, I add those exponents, so x to the 5th, and it will remain the 8th root. Okay. We'll come over here to this example. Alright, in this scenario right here, I'm multiplying the square root of x plus 7 times the square root of x minus 7. Now, you do need to keep in mind these are considered binomials underneath there. Alright, so when I multiply those, I'm going to have the square root of an x plus 7 times that x minus 7. Okay, now you could go ahead and FOIL and multiply this out, or if you recognize that this is the factored form of the difference of two squares, then you can real quickly multiply the first term, x squared. If it's going to be the difference of two squares, I would have a minus, and then squaring that second term will give us 49. Okay, now on this one, this is our final answer. Alright, if you remember what we talked about in section 7.1 as well as 7.2, alright, some people are going to look at this and go, oh, I can take the square root of x squared, I can take the square root of 49. However, that is not the case. This is not equal to the square root of x squared minus the square root of 49. Even though those two things are perfect squares, you cannot do that. Alright, so if you don't remember that, refer back to your notes from section 7-1 and 7-2. Okay, taking a look at these 4 examples, it really doesn't make any difference what's underneath. In this scenario, I've got some little rational expressions here. All right, I'm still going to multiply them just like I normally would. When I multiply fractions, I multiply straight across the top, straight across the bottom. So I'm going to have the 4th root of 3 times x on top is going to give me a 3x. The y times the y on the bottom is going to give me a y squared. Alright, on this one, again, I've got some... this is an x minus 2 raised to the 3rd power, and this one, even though it doesn't originally have a set of parentheses around it, it's still a binomial, and it's got that imaginary 1 right there. So I will have the 6th root, and then when multiplying like bases, we add those exponents. My base in this scenario is x minus 2. Alright, so x minus 2, and then to the 4th power, adding those exponents. Okay, down here we're going to, again, have the 7th root of both of these, so I can multiply what's underneath. I'm going to take a look at those coefficients. I'm going to multiply the coefficients like normal. So I'm going to have a 7th root here. 11 times 7 is 77. Taking care of the x's, when multiplying like bases, we add those exponents. So x to the 5th. And when multiplying the like bases of the y's, we're going to add those exponents and remember the imaginary 1, so we'll have y to the 3rd. On this last one, another one with some fractions underneath there. Alright, multiplying straight across top, multiplying straight across the bottom, that's going to give me the square root of a 10x over a 10. Alright, if you do end up with something like this and you've got like that 10 over 10 in there, go ahead and simplify that down so that we're going to have just a nice little square root of x. Alright, so really just 4 quick examples of how you are going to multiply radical expressions. Definitely thanks for watching. If the videos are helping, please share with your friends, and don't forget to subscribe to the channel. Thanks.